Okay, so for problem number 1, as we look at this, this is an angle bisector. So the questions are for exercises 1 through 3. Tell whether the information in the diagram allows you to conclude that the point P is on the perpendicular bisector of RS. Okay, well, or if it's an angle bisector of DEF. Now they say angle DEF, but if you notice, like, there's only one triangle that has the DEF. So they kind of give the answers away, but that's okay. We want to look at this. This is an angle bisector, and the way that I know that it's an angle bisector is that TS is congruent to TR, that RP is congruent to SR. So that categorizes that as an angle bisector. But it's also a perpendicular bisector because it's this line TP, so TP is perpendicular to RS, right? And RP is congruent to SP. So we would call that a perpendicular bisector. It's also an angle bisector too, because these two angles would be congruent. You couldn't have all these congruent sides if they weren't congruent. Okay, so there's two theorems that we're working with, and one is the angle bisector, the other one is the perpendicular bisector. And we have to be careful because the perpendicular bisector is referring to line segments, but an angle bisector is referring to angles, right? This one happens to be both, okay? So we're just going to look at that. And then the other thing, just because you see a 90-degree angle, and there's a converse of it too. So what we really need to be able to do is identify congruency, because that's what really matters. I'm not going to be so hung up on the formality of knowing if it's the converse perpendicular bisector theorem or if it's the I just want to make sure that you guys understand what's congruent and what isn't. Now this one, this is congruent and this is congruent. If this forms a 90-degree angle, then that one forms a 90-degree angle. However, I'm not quite sure if that's enough to prove congruency. We don't really know for sure. And then one way we could double check that is we could look at the theorem. So for problem number 2, let's just go ahead. What I want to do is I'm going to look. It is a perpendicular bisector because T is equidistant from the endpoints R and S. T lies on the perpendicular bisector of RS by the converse perpendicular bisector theorem. So if we go back to look at that, this is yes, and it's by the converse of the perpendicular bisector theorem. Okay? And then it says, and this is an interesting one, for number 3, because this is a 90-degree angle and this is a 90-degree angle, and more importantly, because these two line segments are congruent, then we could say yes. Again, we could say yes. But the question is it an angle bisector? In other words, does EP bisect the angle DEF? Are these two sides congruent? That's really technically what the question is asking. So if we go back, we say yes because it's P is equidistant from ED and equidistant from EF. And so this is the converse of the angle bisector theorem. So this is the converse. So yes, and this is the converse of the angle bisector theorem. Did I say perpendicular? Okay, angle bisector theorem. Okay, and so basically the perpendicular bisector theorem and the angle perpendicular bisector, and the angle bisector theorem it proves congruency. These are really triangle congruencies, and we're just applying them to this situation. You notice that this is a triangle, right? So technically you have a side and you have a side, so that means this is an isosceles triangle, so that means angle S is congruent to angle R. And then because it goes through the midpoint, that's the only way that these two sides can be congruent, then I know it's an angle bisector, and also through the congruency of the two triangles, I know that this angle is congruent with this angle. It's a perpendicular bisector on the segment here, but it's also an angle bisector. If we look at this one, we technically have side angle, but you can prove the congruencies. This is the perpendicular bisector theorem. If this is perpendicular, then it goes through the midpoint here because these two sides are congruent, therefore this is congruent with this one. So that's why it's called the converse. We're working backwards. Okay, here we could prove congruency of the perpendicular bisector, but here, because we know it's a perpendicular bisector, we can prove the rest is congruent. And then the same way here, because this line segment and this line segment are congruent and these are equidistant, we know that because of these perpendicular angles, then we go back and prove that this is an angle bisector. So it's the converse, so we're working backwards, okay? So with all that being said, this is 8.4, this is 8.4. I know that these two are congruent. I know that this is a 90-degree angle. And even if I just use my triangle theorems, this line is congruent to itself. So I have side angle side. That means that those two little triangles are congruent. So what is AD? 20. See how that works? You got to look for the clues. Okay? So AD is equal to 20. For problem number 5, what do we know about 4x plus 5 and 2x plus 11? They're congruent. So I'm going to say that 4x plus 5 has to equal 2x plus 11. So now I'm going to solve. I'm going to subtract 2x from both sides. I'm going to get 2x plus 5 is equal to 11. I'm going to subtract 5 from both sides. I get 2x equals 6. Divide both sides by 2. I get x equals 3. They want to know what GJ is. GJ is actually 2x plus 11. We know that x is going to be 3, so we say 2 times 3 plus 11. What's 2 times 3? Plus 11? 17. You guys were counting on your fingers. That's good. Okay, I'm going to double check. Remember, Mr. Adams posted the solutions. And I posted the solutions on my website, so yeah, it is 17, okay? All right, let's go to problem number 6. PQ is what? PQ is what? If this angle is congruent and this angle is congruent, and this side is congruent, then I have angle, side, which means the two little triangles are congruent, so it's 14. Yeah, he's going, 14? It's 14. I'm trying to explain why it's 14. What about these two angles? Are those two congruent? Yep, because this is equidistant, and we have our 90-degree angles. So then, also it's, so I'd say 3x plus 8 is equal to 5x minus 12. I'm going to subtract 3x from both sides. I get 8 equals 2x minus 12. Add 12 to both sides. I get 20 equals 2x. Divide by 2. Divide by 2. I get 10 equals x. We want DGF. So that's going to be 3x plus 8 is equal to 3 times 10 plus 8. What's 3 times 10? And plus 8? Yeah, so this whole thing equals 38. Okay? Let's double check our solutions that Mr. Adams posted. Oh, wait, you know what? Read the directions real careful, right? It says what's DGF? So that's DGF. What did I find? DGE. So technically, what is that? So that means this is 38, right? So then, what's 38 plus 38?
69.
No. I'm recording, by the way. It's going to be great to play that back for Mr. Fisher. 76 degrees. 38 plus 38 is 76 degrees. Any questions on that? We got to read the directions. Even Mr. Adams makes mistakes. Okay? That's why we always double check. Now, what I'm going to do is we're not going to do problems 8, 9, and 10, so just cross those off. Okay? Yeah, here. Can we keep moving?